Late Cenozoic volcanism of the Caucasus. An important feature of the area of syntaxis is a large belt of late Cenozoic, up to practically present-day, volcanism, which extends in submeridional, Trans-Caucasian, direction from the eastern Anatolia via the Lesser to the Greater Caucasus, where large Elbrus and Cosmic volcanoes occur. Volcanics of this belt on their petrological and geochemical features are often close to the supersubduction calc-alkaline magmas, and represented mostly by basaltic andesites, and dacites under subordinate role of low T basalts and rhyolites. Koronevsky, Domina, 2007, Keskin et al., 2007. Volcanic structures themselves with a lot of calderas and acid pyroclastics are also very close to the volcanoes of island arcs and active continental margins. Along with this type of magmatism, extensive lava plateaus, formed by eruptions, often fissured, of moderately alkaline basalts of within plate type, such as Javaheti, Gekhama, Siunik, Kars, and others, are also observed in the region. Volcanics of the calc-alkaline series, supersubduction type, is of a prime interest. In contrast to the island arcs and active continental margins, East Anatolian Caucasus volcanic belt stretches across the overall structure of the Greater Caucasus, following the direction of positive Transcaucasian isostatic anomaly. Just south of the Van Lake, this belt is divided into two branches, one of them can be traced to the west, to central Anatolia, and the other, to the east, toward the Elbrus and the Zagros. Moreover, although the Arabian Caucasian syntaxis is characterized by high seismicity, the earthquake hypocenters with depth not more than 50 to 60 km dominated, and deep focus earthquakes, up to 120 km, are extremely rare and occurred only in the eastern part of the GC at its border with the Caspian Sea, figure 5 and 6. From this it follows that there is no any subduction beneath the eastern Anatolia, Sanvil et al., 2003, and Caucasus at present. Isotopic and geochemical data suggest that origin of magmatism of supersubduction type associated with interaction between a mantle plume head and continental crust material, Lebedev et al., 2006, 2011, Chugov et al., 2012. Judging by the fact that the orientation of East Anatolian Caucasian zone, where joined Anatolian Caucasian and Caucasian Albertian arcs, practically coincides with the zone of syntaxis, i.e. with the area of maximum stress, we think that melting of crustal material and processes of deformations at high pressures played an important role in generation of these magmas. As shown earlier, crystal lattice of minerals under such conditions is at the stress state, which making them easier to disintegrate, and the conversion to the liquid phase requires much less heat. Sharkov, 2004, and references herein. An essential role in this process of melting can play frictional heat generated during deformation. Frischabutter, Hanisch, 1991, Molnar, England, 1995, and mantle fluids from degassing due to decompression of the plume head, which penetrated a deformable crust, introducing some warmth in some components. How it is determined by isotopic and geochemical methods. From this standpoint, the emergence of the Anatolian Caucasian and Caucasian Albertian arcs may be due to the diffluence of deep-seated crustal material to both sides from the Arabian indenter, fixing appearance of foci of melting related to the tectonic flowage of material. In other words, these volcanic arc trace suture zone, on which outflow of crustal matter from the stop of the Eurasian plate occurred in the process of continental collision. Likely, the location of these suture zones was determined by configuration of the plume head, which extends to the north and oncoming streamlined from the both sides by tectonized material of shallow lithosphere. Distribution of the earthquakes in the region. Shallow focuses sharply predominate. Distribution of earthquake focuses beneath the volcanic area eastern Turkey, Caucasus. Similar isotopic and geochemical characteristics were established for the late Cenozoic calc-alkaline volcanic rocks in the zone of continental collision in the Alpine Mediterranean region, where these features of magmas are usually explained by the complex composition of the mantle sources, strongly contaminated by crustal material. Harangi et al., 2006, in references herein.